Hello, I'm Renato Figueiredo from the University of Florida, and on behalf of the IPOP project, I'll give a brief introduction and demonstration of GroupVPN. What is GroupVPN? It's a self-configuring virtual private network that enables you to create groups of users or clusters where you can have private communication among endpoints. One important thing in GroupVPN is that it runs existing IP-based software. So games, streaming, file sharing, any type of software that runs over IP v4 or IPv6 works on GroupVPN unmodified. And it creates peer-to-peer links, allowing computers to communicate directly with each other without going through a central infrastructure, like typical VPN software. GroupVPN provides all-to-all connectivity within a group, so all machines that are connected to the same group are able to communicate with each other, even if they are constrained by firewalls or nets. GroupVPN is an open source project that is part of IPOP, and it's user-level software that runs on every device. We use an XMPP server to connect to and obtain social relationships, in this case, a membership in a group. And one example of XMPP server open source that's available for use with GroupVPN is EdgeVPN-io. So in this demo, what I'll show you is 3 nodes that will create a group. In fact, we'll have a group with 40 nodes, but I'm going to highlight only 3 nodes talking to each other. So they'll use an XMPP stun server to discover each other and request to connect to each of these nodes. And after running social VPN, GroupVPN and connecting to the server, GroupVPN links will be established between these nodes automatically, and nodes will be assigned private IP addresses in the IPv4 space. They also get assigned private IPv6 addresses, and I'll show that in the demonstration. So here I am connected to a virtual machine running on the Future Grid infrastructure, and this machine is running GroupVPN. As you can see, there's an IPOP virtual network interface installed in the system, and it has a private IPv4 address 172.16.1.2. And this machine can ping other machines in the virtual network. This case node 1, and you see the latency of a ping operation to that node, and it can also ping node 3. These nodes are connected as part of a larger group of nodes, and if I go to the XMPP server, you can see the status of all nodes that are connected to this GroupVPN. There's a total of 40 nodes in this example running on virtual machines in the cloud. So these links connecting GroupVPN nodes have been pre-established. If I try to connect to another GroupVPN node, for example, node number 6, you'll see that it takes a few seconds for a connection to be established, and then eventually connectivity is created by a direct link, peer-to-peer link between these 2 nodes. You can also see that there's an IPv6 address for the virtual interface in IPOP, GroupVPN, and you can use that interface to ping using IPv6 another node that belongs to the same GroupVPN. In the example that I showed in the demo, we looked at the so-called OnDemand Connections, and this allows nodes to be created only when there's traffic detected between the 2 nodes. When I pinged machine number 6, it took a few seconds for that to take place and for the on-demand network to be created. This scales better, and for smaller networks, you can also use a proactive mode where nodes are always, links are always created between nodes when they are both online. And this lowers the latency for the first packet by proactively creating new links. Where do you go from here? You can go through a demo that will essentially follow the same steps that I did for this tutorial. If you go to our website, ipopproject.org, and search for our tutorials, you'll be able to follow this on your own using virtual machines. You can subscribe to our mailing list and participate in the project by using and contributing code to this open source project. Thank you.